Any 40E series routers support either centralized NAT or distributed NAT. Let's look at each of these modes. In centralized NAT mode, a standalone device provides NAT functions. This device is attached to a core router, CR, or a broadband remote access server, BRAS. Centralized NAT is deployed in areas where the distribution of private network users is sparse, or in scenarios where devices on a live network cannot be upgraded to support carrier-grade NAT, CGN. In distributed NAT mode, NAT-capable service boards are installed on a device, for example a BRAS, to implement NAT functions. CGN functions are deployed on service boards of each BRAS, which is called distributed NAT. Now let's move on to the centralized NAT networking. PCs on the intranet of a company need to connect to the internet using NAT functions provided by an NE40E. Interfaces 1 and 2 of the router connect to the internet and internet respectively. The company is assigned 5 public IP addresses, 11.11.11.1 through 11.11.11.5. The following requirements must be met. 1. PCs on the internal network segment 192.168.10.0 with a 24-bit mask can access the internet, but PCs on the other network segments cannot. 2. Conversion is implemented between private and public IP addresses. Here is the configuration roadmap. Step 1. Configure basic NAT functions. Step 2. Configure a NAT traffic diversion policy. Step 3. Configure a NAT conversion policy. Next, let's look at the configuration on the router. Step 1. Set the maximum number of NAT session tables that can be created. This number is controlled by a license file. The device defaults to not allocating NAT session table resources. However, you can adjust these resources as needed when configuring NAT. A VSUF160 service board is used in this example. Set the maximum number of session tables that can be created on the NAT service board to 16 million in the license view. The NAT service board is installed in slot 4 of the router. Step 2. Create a VSM HA backup group and access the VSM HA backup group view. Bind the group to the CPU of the service board in the VSM HA backup view. Step 3. Create a VSM HA service instance group and bind it to the VSM HA backup group. This configuration binds the service board to the NAT instance. Next, let's see how a service board is bound to a NAT instance. You can see that a NAT instance named NAT1 is created. The service instance group command is run in this NAT instance to bind the VSM HA service instance group to the NAT instance. In this case, the service board of the VSM HA service instance group is also bound to the NAT instance. Next, configure a NAT address pool. The address pool contains 5 public addresses, 11.11.11.1 through 11.11.11.5. The public IP addresses in the address pool are assigned to private network users after NAT conversion is performed. As mentioned before, the company wants to allow PCs only on the private network segment, 192.168.10.0 with a 24-bit mask to access the internet and prevent PCs on the other network segments from accessing the internet. To meet the requirements, an ACL is used. Create an ACL numbered 3001 and access the ACL view to create an ACL rule numbered 1. Users only on the network segment 192.168.10.0 with a 24-bit mask can access the internet using NAT. Traffic diversion in centralized NAT mode is performed using either an outbound or inbound interface diversion policy. In this example, an outbound interface traffic diversion policy is used. Packets matching the traffic diversion policy are imported into the service board for NAT processing. The outbound interface is GE305, which is assigned 11.2.3.4 and implements the diversion policy. The last step is to configure a NAT conversion policy using the NAT outbound command. Traffic matching ACL 3001 is diverted to the service board, and the NAT address pool named address-group1 is used to perform NAT conversion for the traffic.